Session from Google Inc. would like to invite Mr. Ryan Boyd under the title of Introduction to Google Data APIs, Mashing Up Google Calendar, Spreadsheet, and more.
Good afternoon. My name is Ryan Boyd. I'm from the Google Data APIs team, and I'm here today to talk to you about an introduction to GData-based APIs. I'm going to start off with overviewing the protocol, what it means to be a GData API, and that's going to include things like the actual transmission protocol and the data format. I'm then going to give an overview of the different types of operations available in all GData APIs. And that is going to be in the raw XML and HTTP requests and responses. And then I'm going to give you a little bit of an application sample that will show the use of the APIs. Google offers many different APIs across a variety of different services. These APIs are of different types. We have APIs that are meant for more desktop applications, such as our AJAX APIs, including things like Google Maps and AJAX Search. We also have APIs that are based upon SOAP, such as the AdWords API, and there are other APIs for each of our various services. Google Data APIs were created in order to solve a component of Google's mission. Google's mission is to organize the world's information and make it universally accessible and useful. So GData APIs were created in order to provide a common interface across a variety of different services, exposing this data through ways other than a web browser. Because making it universally accessible means having it available outside the context of a web browser. Here's a quote from a blogger shortly after GData APIs were launched. The benefit of GData is that you have a single API that can be used to query, update, and index structured data on the web, anywhere on the web. It's a pretty powerful vision and something I didn't expect to see for a couple more years. GData APIs are based upon a standard protocol, the Atom Publishing Protocol. The Atom Publishing Protocol defines a simple format for use of its data, and that format is the Atom syndication format. You guys may be familiar with that as it's used often in the blogging world. And it also defines the protocol to transmit the data back and forth to perform various options, and that protocol is HTTP, which we all know and love. Google Data APIs extend upon this using a variety of extensions. These extensions are based upon the built-in extension model that's part of the Atom Publishing Protocol. And these extensions include things like a data model that's specific to Google services, includes the ability to query data in Google services, and also provides a thing called concurrency, which is kind of like a versioning system that we'll go into later, and authentication. Here's an example bit of data from a GData service. This is, in large parts, well, it's all XML, and in large parts, it is just standard Atom elements. So here are the Atom elements highlighted. These are part of the standard Atom syndication format. So everything that's highlighted in blue here is part of a standard Atom entry. And this entry as a whole represents an event. We'll say an event on Google Calendar. And so the words highlighted in blue are part of the standard Atom syndication format. And then the extensions that I talked about are highlighted in red here. So we extend the standard Atom syndication format to indicate things like a time for an event. So this is in the GD namespace, which is what a lot of the GData elements are in. And this defines the start time and end time for the event and specifies a reminder for the event, which like in Google Calendar is something like a pop-up in your web browser. It also defines where the event is supposed to be located at in Building 41, which is a building on Google's campus in Mountain View. and defines the status of the event. This is a confirmed event. And lastly here, we have the visibility. It's a public event. At the top here, we see this category tag. The category tag represents the idea that we are, this entry is formatted in the kind, the event kind. A kind in GData is a collection of common elements that in theory could be used across a variety of different Google services. This event kind right now is actually only used in Calendar, but it's structured in such a way that other services, if they expose entries which they would like to call events, can do so and use the same format for their data. Okay, one of the other extensions is the query model. The query model allows you to filter the results you get back from the various Google services. There are a number of different types of queries. Some of the queries are available across multiple Google services, and some of the queries are specific to an individual service. We start off here with the full text query or full text search. So this is searching for in this feed called friends. It's an arbitrary, the feed doesn't actually exist, but we're searching in this feed called friends for the name John. As a full text query, it's searching all the text-based content of the entries in that feed. So for instance, it could be John is your friend, or it could also be something like John is a friend of a friend, and you know, his name is mentioned in one of your friend's entries. This next type of query is based off of categories or tags. So a common thing in many web applications nowadays is to tag individual entries with a word. In this case, we are querying for all entries in the friends feed that are tagged with either the word work or play. So your friends that are either you know through work or you know through personal relationships, it's searching for all the entries that are tagged with that. So you can see the dash here. The dash separates the idea of the actual feed that you're trying to retrieve from what are the categories. And right now, because there is this symbol in between, the pipe symbol, that symbol represents the idea you're doing an OR query. If instead we had another slash, if we had a slash here, it would be friends that are work friends and play friends. This other example here is searching based off the updated time. Every entry, because we use the Atom syndication format, every entry has a time associated with it when that entry was last updated. So in this query, we're searching for entries which have been updated since 2005, August 9th. That is available across most of the GData services. The next thing I want to talk about here are custom search queries. So there are some search queries which may make sense in particular products, but not in others. For example, Spreadsheets supports a query parameter called minRow and a query parameter called maxRow. What this allows you to do is retrieve specific rows from your spreadsheet. So if you wanted to retrieve rows 1 through 3, you would set the minRow query parameter to 1 and the maxRow query parameter to 3. There are other query parameters that are used throughout a variety of different services. To give you another example, Google Calendar supports a query parameter called startMin, and another query parameter called startMax, which allows you to search for events that are taking place during a particular period of time. Then lastly here, we have the output format query parameters. These aren't used really to change the filter the entries that are returned. It's used instead to change the format which the entries are returned in. By default, all GData services will return their entries in Atom format. However, we also support other standards such as RSS and JSON as different output formats. In this case here, we're saying we want to use the JSON format. So we're going to retrieve the the friends feed, but we're going to be using the JSON output format. I'm not sure, how many of you are familiar with what JSON is? Okay. So let me just explain here quickly for those of you who aren't familiar with JSON. JSON is a specific format for data that's used very heavily in JavaScript applications. It stands for JavaScript Object Notation, and it's really easy to use from within JavaScript applications. Some people have also used it in other types of applications on the server side in PHP and Java and that sort of thing. But it's just an alternative to representing your data as XML. Here's an example of an application which uses the JSON output format. This is called Taking Stock of Silicon Valley. And basically what it is a mashup between Google Maps and Google Spreadsheets. So Google Spreadsheets has two functions in it. I don't know if you're familiar with how Excel has functions, but Google Spreadsheet has a similar concept. And you can say Google Lookup and Google Finance are two functions as part of Spreadsheets. So what this does is stores a bunch of stocks that we gathered from Wikipedia and stores those inside a Google spreadsheet. Has a list of the stocks and then uses these Google Finance and Google Lookup functions in order to retrieve information about those stocks. Information such as the current stock price. So you see here at the time that I took this snapshot only a couple weeks ago, unfortunately we were down at that time. That's the red color indicates that the stock is down. If I had clicked instead on one of the stocks that were green, this bar here would be green. But this indicates that the stock price at the time that I took this screenshot, which was a while ago, this isn't the current information, it indicates the price was 466.81. The bar graph here indicates the current stock price versus the 52-week high stock price. So in this case here, we're up about, I don't know, 3/4 of what the 52-week high price was. On the right, we have the price to earning ratios of the various stocks. Just another indicator as to the performance of the various Silicon Valley stocks. And this was just done as an example of how you can use the JSON output. So all this does is there's no server-side logic. This is an application based purely in JavaScript. It retrieves the various stocks from Google Spreadsheets and then takes that information and plots it out on a map. Okay, so the Atom Publishing Protocol. I want to put a little perspective on what the Atom Publishing Protocol means. The Atom Publishing Protocol uses standard HTTP methods or verbs in a very similar way to what you use in a web application in your web browser. So for instance, in order to retrieve and enter your feed, we use the HTTP GET verb. This is very similar, or exactly the same, as when you type in a URL into your web browser. So if you go http://www.google.com, your browser performs what's called an HTTP GET request. GET is the verb in this case, or the HTTP method. And that's basically used just to retrieve data. GET, by its definition, shouldn't be actually updating data or deleting data or doing anything like that. It's just used to retrieve data. There is also the HTTP POST method. The POST method is most commonly used in a web browser when you submit a form. Most forms use POST, not all, but most forms do. When you actually fill out information such as an order form, if you were trying to buy a product, that's using the HTTP POST method. And then there's the delete and put methods. Delete and put methods are not actually commonly used in web applications nowadays, but have been used in the past with other protocols, such as WebDAV. Okay, so that should give you a little context for the different methods discussed here with the Atom Publishing Protocol. So I'm not going to go through this in too much detail because I think you got a lot of that from the last slide. But here is how we retrieve and enter your feed, use the HTTP verb GET. We post new data using the HTTP verb POST. So this is for inserting a new entry, such as a calendar event or a Picasso photo that sort of thing. Put is used for updating an entry. So the same way as you use post, post is used, you say post, then the URL, and then the body of the HTTP request includes the actual content of the entry. Put does the same thing. The only thing that's changing between a post and a put is changing the verb. The data and where it goes is the exact same place. And you'll see this shortly here as I walk through some examples in raw XML and HTTP. And then delete. Delete is probably one of the most simplistic operations. You just say delete and then the URL. And that deletes the entry from the server. Before I go into those detailed examples using the raw protocol, I just want to give you an idea of the wide variety of services that offer GData APIs. To start off here, we have Google Apps. Google Apps has a provisioning API. That API allows you to create new users. So if you have a Google Apps domain, you can create new users that would then be able to access mail on your domain or a calendar on your domain, that sort of thing. I'm going to be skipping over a couple here just to highlight some. Google Calendar is the popular Google Calendar service, offers an API that allows you to access all events on a calendar and update events, delete events. Also, they recently added functionality to allow you to manage access control lists. So you can manage the privileges for your calendar, who has access to which calendar. And then some more interesting ones, Picasa, for instance, is our first API that we've released, which allows you to edit multimedia content. So it allows you to actually update photos, insert new photos, and edit the metadata associated with those photos. And then Spreadsheets, which we'll be talking about here more in an example later. Spreadsheets allows you to access everything you can access with the normal Google spreadsheet, except programmatically. So it basically can act as a very, very simple database. So the next couple examples are going to work with a fictitious service. That fictitious service is going to act mostly like a blog, but I'm not using Blogger specifically here. I'm trying to use a general representation of what GData services offer. And I'm going to guide through each of these items here. So I talked about how you add a new entry using the HTTP verb post. Here's an example of doing that. So in this case here, we're doing a post / my feed, our fictitious service or fictitious feed. And we're specifying the entry in the body of the post. So this entry is a very simple entry. This actually doesn't use anything specific to Google Data APIs. This uses the XML elements that are common across all Atom entries. So in this case, we're saying the author, their name and email address, and we're also saying the title of this entry and the content. Very simple. The server will respond with an HTTP status code 201 created. All of GData services use the same standard HTTP response codes. We're not trying to reinvent the wheel here. So 201 created, anything in the 200 range is a successful response. 300 range includes things like redirects, and 400 and 500 range include errors. So in this case, it was successful. We created an entry, and that entry was created. All these gray or black elements were things that we originally supplied to the server, and then the red elements are things that the server added after it created the entry. So we created the entry, and the server added in the response, the ID of the entry, a link that allows you to edit the entry, the published date, and the updated date. So the initial request actually did not include an ID. Some of you may know that the ID element is actually a required element in an Atom entry. Our servers in general will allow you to submit entries that are not ATOM compliant. Of course, it allows you to submit entries which are ATOM compliant as well, but it allows you to submit these ones that aren't ATOM compliant. But the response from the server will always be ATOM compliant. We try to make sure that we're adhering to the standards as best as possible. So the responses will always be ATOM compliant, but things like the ID, you actually don't know the ID at the time that you add this entry. So the server adds it for you. Okay, so now we just added this entry. The entry had an author in it. The author's name was Elizabeth Bennett. Let's say we want to query all the entries with the word Bennett. This is using the full text query parameter called Q, and is using the word Bennett as the value of that query parameter. This allows you to search for all the entries which contain the word Bennett. So we can see here, there's only one entry returned. The one entry is the entry that we just added with the name Elizabeth Bennett as the author. That's just a simple demonstration of the query parameters. Of course, like I talked about earlier, there's a lot more complex query parameters, but the full text query is available across most GData services. Here's an example of updating an entry. So for updating an entry, we use the HTTP verb put, and we're putting it to the edit URL. You noticed in the last response, so if you notice in this response, we have an edit URL here. That is the URL that we want to use when we're doing the put. So in this case, we're using that edit URL. We're doing a put to that location, and we're putting the contents of the entry the same as it existed in the server response before, but updated the actual content. The content is updated to say, this is my updated entry. The server is now going to respond with a 200 OK successful response code. This response code includes the updated entry content. Basically, it was successful at updating that entry. It also includes a new edit URL, /1/2, specifying that is the second version of the entry. And the updated date has changed because the event has been updated. I'm sorry, the entry has been updated. This is an example of deleting the entry. So to delete an entry, it's very simple. You just send delete and then the edit URL for the entry. So we delete /1/2 and we get a 200 OK response code. Let's say, for example, though, that we try to delete version 1 of the entry. So entry number 1, version 1, no longer exists. Well, I mean, it exists, but it's been replaced by version 2. So if we try to delete version 1, the server will return a 409 conflict error. This is what we call optimistic concurrency. It's another extension that we added to the ATOM processing protocol. And what optimistic concurrency does is prevents you from updating or deleting entries based off of old information. Many of our services implement the optimistic concurrency, but some services don't. It is an optional thing for GData services to implement. Okay, you may have noticed we're doing lots of things like deleting entries, updating entries, things that you normally wouldn't be able to do unless you were authenticated in some way. Of course, we don't want to allow the entire world to delete the entries on your calendar or update the entries on your calendar. So we have various methods of authentication. There are two methods that are available across all GData services. And those methods are authentication for desktop applications. If you look on our documentation, you'll see this referred to with those words and also with the term client login. Authentication for desktop applications basically means that in your application, you are requesting the user enter their Google account credentials, and then you're submitting those Google account credentials to Google directly and getting an authentication token back. That authentication token can then be used to access our individual services. So the authentication token can be used to then, say, insert an event on a calendar. But this method does require that your application deal directly with the user's credentials, the user's username and password for their Google account. So that's where this other mechanism comes in. This mechanism, called authentication for web apps, also known as authsub, is a mechanism used to prevent your application from having to deal with a user's credentials directly. Basically, with this mechanism, the user doesn't enter their credentials into your application, but instead enters them directly into Google. So your application doesn't have access to those credentials. Here's a diagram of what happens when you are using the authsub authentication mechanism. You guys will actually see this a bit later in a demonstration application. But basically what happens is the user visits your web application. The web application says, hey, you're not logged in, and sends a response back to your browser. And you're told your browser to, hey, send this person over to Google. They go over to Google. They log in with their credentials in Google securely, and then get redirected back through the browser to your web application. And it includes a token at that point. This token is what you can use to have one-time access to the person's Google account for a particular service. Or you can also, if you specified initially that you wanted it to be a session token, you can then upgrade that token to have multiple access, basically indefinite access until the user revokes it, to a particular service under that user's Google account. I want to stress here that all web applications should really use the authsub or authentication for web apps mechanism. You should not be using the client login or the desktop app mechanism in web browser. This is in order to protect the user's account credentials. Okay, so a lot of this stuff is a little bit complicated and detailed, and if you're not really technical and really into HTTP or into XML, you may not know how to work with these services. While they're very simple, if you're into those protocols, they can get a little complex if you're not familiar with XML and HTTP. So we have written a number of client libraries which we've open sourced. These client libraries are things like a Java client library, .NET client library, PHP, Python, etc. And these client libraries can actually be used to work with all GData services in a method that doesn't require you to know the raw protocol. So what the client libraries do is provide methods such as, for Google Calendar, a method called insert event, that you then pass an event object. And that event has a thing called title and a thing called when and where. Basically, it allows you to use our applications as if they were a local API for your programming environment. We also have an active developer community surrounding our APIs. This active developer community congregates on a Google group that we have set up for each GData API. The Google group is basically a forum for discussion. People can go in and post their questions, their problems, bug reports, that sort of thing. And there are people at Google who occasionally read these posts, and there are also people in the outside world that read and respond to the posts. And inside the groups, we have a new feature we launched based off of a wiki mechanism that allows you to share your project with the world. So if you have a really interesting project that you've done using our APIs, you can go to the group for your particular service. So let's say there's a group for calendar, and you can say, hey, here's this great project I've done, here's the URL, here's a short description, and share that project with the rest of the world and hopefully inspire some creativity in others. And that's also a place you can do things like filing feature requests. So this group, this community of users using our various APIs have also discovered that there are places that they would like some client libraries that we don't currently offer. So there is, a Ruby community of developers, a Perl community, a Lisp community, people that are working in different languages other than those that we've chosen to release client libraries currently. And they have actually developed client libraries and released them as well. Now, these might not be as fully feature-rich as some of the client libraries that we've released, but they meet the purposes of their developers that have developed them. And they've submitted those out to the world for other contributions for other use. So check them out if you're using one of those languages. Documentation is obviously a very important component of all APIs, and pretty much of everything in the computer world, documentation is very important. So we recently actually released some developer guides that are specific to individual services and specific to programming languages. So we take all the important operations in a particular service, and we take all the important languages, or we try to get all of them, and we write these developer guides, which they're based off a tabbed layout. And if you go through each of the tabs, you can see, for example, how to add an event in Java versus how to add an event in .NET versus how to add an event in Python or PHP. And we also have a knowledge base. So the knowledge base is for a different format for our documentation for people who like the format of the documentation in a question and answer method. All right. Now on to some exciting stuff. Some things that people have done with our APIs. Here's an example of several products that people have developed with our APIs. The first one here, called Ambient Clock, is actually intended eventually to be an embedded device, a actual hardware clock that you would sit on your nightstand. And what it does is actually displays a normal clock, and then the highlighted areas, or the black areas here, represent the times that you have meetings on your Google Calendar. Now, they actually haven't released a physical device yet. What they've released is an iGoogle gadget, and the iGoogle gadget is intended to be a beta to see how people like the product in the end. So it's a really good way to test out their audience, see if everyone likes their features, and get some feedback on that. And the second one here is something that is used to keep track of timesheets, and it uses a combination of the Spreadsheets API and the Calendar API. And then the last one is a photo editor called Fixer. It allows you to edit your photos that are stored in your Picasso web albums. Here's an example of another photo editor. This photo editor is called Picnic. What I'm doing here is loading a photo from Picasso web albums through the API. I'm cropping the photo, and after I have the photo cropped, I'm then saving the photo back to my Picasso web albums for all my friends to view. A really cool way to work with the Picasso API. A lot of other applications have been developed with the Picasso API, including things to allow you to print out your photos into physical books and that sort of thing. Okay, the next part here, I'm going to dive into an event publisher. You guys probably saw this in the abstract for this talk. And the event publisher is being used to publish events from Google Spreadsheets to Google Calendar and Google Base. Now, why might you want to do that? This actually stemmed out of the need for a mashup to demonstrate at Mashup Camp a couple months ago. And it also stemmed out of a problem we actually have at Google. So on google.com, I'm sorry, in code.google.com, we have a event calendar that lists all the developer events that are upcoming. Things like this, or things like conferences that we're attending. So things like, you know, conference, or other conferences that Google employees are attending and presenting at. So this calendar has all these different events, but Google employees actually need to put events into that calendar. And these are Google employees across the entire organization. So they need to be able to maintain this list of events. Some of the events haven't been approved yet. Some of the events haven't even had a proposal submitted yet, but are just things people would like to track. And then there's other events that have been approved. So what we try to do what we do is maintain a Google spreadsheet that includes the list of each of these events. And there's a separate column. In addition to the normal columns, such as the description of the event, the title of the event, I'm sorry, that title and description are very close, the date and the time of the event. There's also a column that says whether it's been approved, whether it's been published. So this allows them to maintain extra information than what's actually displayed on the outside calendar. So that's where part of this idea was born for this application. So what this application does is takes information from a spreadsheet and publishes it to calendar or base. Okay, so I've loaded this application. This application is a Java-based web application using our GData Java client library. And I've loaded this application as in my web browser. It's hosted on a local instance of Jakarta Tomcat servlet engine. And this local instance, it's basically, the whole process is built using Ant, and it's a Java application. It's distributed as part of our Java client library now. So if you download the most recent version of the Java client library, you can find this application. So the first thing I'm going to do here is authenticate to my Google Spreadsheets account. So this is the authentication for web applications, or auth mechanism of authentication. So what I'm doing here is I'm currently logged into my Google account, and what this is saying is that we want access to your Google Docs and spreadsheets, we being the application, and we'd like you to grant access or deny access. You see also the yellow warning box here. The yellow warning box represents that the application was not registered with Google. A registered application basically provides us a public key, and they use a private key to sign the request back and forth. So this application wasn't registered, and you can find out more information on how to be a registered application on our website. But that's why this yellow warning box is presented. So what I'm going to do here is going to hit the Grant Access button. And this lists each of the spreadsheets that are available in my account. So what it does is goes off using the GData Java client library, and it's performing an HTTP GET to the list of spreadsheets that are in the account of the authenticated user. So you can see here I have 4 spreadsheets. The one that I'm concerned about here today is the developer event spreadsheet. So I clicked on that, and then it goes off and retrieves the worksheets that are available on my account. Very similar to retrieving the spreadsheets, just in this case, it's each of the worksheets. So we're concerned with the event list. So let me actually show you what this spreadsheet looks like. Here's an example of the spreadsheet. Hopefully everyone can read that. So the spreadsheet lists the title of the event, description, start date, end date, the website the event is located at, the location, and then these two other things which I'll talk about here shortly. So the first thing I want to do is map up the various fields that are needed by the application to what's available in my spreadsheet. This allows someone to have a spreadsheet that has all sorts of different data or different column headers and allows them to map that data up appropriately to what's needed by the application. So here the title is the title. On the left is actually the data that's needed, and on the right is a list of each of the fields from the spreadsheet. So the description, I want to be the description. I'm going through each of these. They're very similar. One thing I'd like to point out is this, this application right now is a demonstration application. The application isn't intended to be, isn't intended for production use. So if you were writing a production application, you might actually want to have some sort of logic there that says, look for the word description in one of the column headers in spreadsheets and map that up automatically. So you didn't have to go through and select each of these. Then I'm going to click Publish Events. So what Publish Events does is lists each of the events out here that are on that spreadsheet and lists information about them. These are stored in the session in the servlet container. And then when we go to the bottom here, we have the option to publish those events to calendar and or base. So I'm going to select both. And what this is doing is going off and publishing the events. And I'll show you here, I skipped over these columns earlier, but I'll talk about them now. The calendar URL and base URL columns are actually the edit links that we talked about earlier. These are the edit links for each of these various events. So the first time that we insert an event into spreadsheets and into base, we grab the edit URL that's returned and store that in the spreadsheet. That way, when we publish the events in the future, we know which events have already been published and need to be updated with the HTTP put mechanism. And we also know what events need to be inserted as new events. So if this was empty, it would need to be a new event. But since it's filled in, it just needs to be updated. So if you see here, this is the URL on calendar for the edit link. So this is the actual entry. You can see up to the slash. Then after this is the version string that's used by calendar. So in the demonstration earlier, I used very simple version numbers like 1 and 2. In many of our services, those version numbers are actually things like timestamps or that sort of thing. But in your applications, obviously if you're working with our client libraries, you wouldn't need to deal with that. And a number is a number. So, all right, so what the application went off and did is publish the events. So where are these events? Here's the Google Calendar for the event calendar, and it lists several of the events here. This is during the month of May, but if I scroll, I actually have some of the other events on the calendar, and then also Google Base. So Google Base, if I refresh here, it was actually listing the events from before the presentation, but if I refresh here, hopefully it'll find them. All right, it's being a little bit slow with the internet connection, but there's a list of each of the events as they appear in Google Base. So the question might be, why do you want to put events in calendar and base? I mentioned the earlier use case because we want the calendar to display on code.google.com. I can actually show that here. But there's also the case of Google Base. And we want events to be in Google Base because events in Base can be easily searched. When you use a search on google.com, you can search events in Base pretty easily, more easily than you can do with Calendar. So here's the event calendar that I was talking about earlier. These events actually currently aren't maintained using this application. Like I mentioned, it's not production quality yet, but could easily be maintained using an application like this. Okay, well here's our website for the GData APIs, and this website can be used to find any information about GData APIs, all the different services, and include more information about the protocol and data format and that sort of thing. So now I'm actually going to open it up for any questions people have. I need to get my earpiece on here, but does anyone have any questions? Okay. I guess that's it. Well, thank you very much. Oh, actually, I'm sorry.
Well, in
the API that you talked about, as much as I know, the Java base is the main, I think. Are you going to utilize other languages? Do you have plan to extend it to other languages besides from Java?
Okay, so the API, GData APIs as a whole, are language agnostic. So you can use the standard protocol we talked about. We do, though, have client libraries that Google publishes in .NET, most commonly used in C#, but also can be used with Visual Basic. We also have client libraries in PHP, Python. I'm trying to think of some of the other client libraries, but we have client libraries in a variety of different languages. So while this example used the Java program, or Java client library, you could do this easily in PHP or one of those other languages.
Thank you very much indeed.
今日のお話を伺うと GData の
Listening to
API っていうのは単純に
today's
ストレージの
presentation,
API だ
then
けで
GData
実際のデー
API
タ
seems to
と
be
か
a
各
storage
アプリケーションの関
API,
連に
and
依存してい
the
ると。
applications
しかもアトムの
are
フォーマッ
dependent
ト
on
でなくて
this,
もいい
and
って
it
いう
doesn't
か
have to be
例えば
atom
オープンのデータ
format.
は勝手にそこに
Then
突っ込ん
Office
で
data could
オ
be
ープンオフィ
placed
スで
in
全
here,
部操作す
and
るっ
with
ていうよう
Open
なことも
Office, it would be
Google
possible
として
to
は全然
manipulate this.
OK なんでしょうか。
Does Google have any problem with that approach?
So the data format we use is Atom because the Atom format is what was most widely available for publishing and syndication. I'm not sure I understand your question directly, but perhaps after this talk we can chat and you can expound on it a little bit more.
あ、わかりました。
I see.
Okay. Oh, just as I say okay, hands pop up.
For the user authentication, you had the page shown. On this page, the language settings, is that something that can be set from the publication side very freely?
So let me bring up that page. Okay, I just want to clarify, is this the page you're speaking about?
Yes.
Okay. The language settings should be dependent upon the user's account that's logged in. I haven't had firsthand experience with this, but depending on who's logged in, different language should be used. For the name of the application, so in this case, localhost represents the name of the application. If you have a registered application, we can do language-dependent settings on those. So we can say, you know, if they're coming from a Japanese account, we can use the Japanese name, or if they're coming from an American account, use the English name, things like that. But
ありがとうございます。
Thank you.
In
the page for authentication,
携帯電話に対応する予定などは
are there any plans to accommodate mobile phones with the authentication page?
I'm actually not aware of whether we do or do not accommodate mobile phones. So unfortunately, I can't answer that question right now, but I can give you my card after the presentation if you'd like me to follow up with you. All right, well, thank you very much.